Hey everyone, this is Derek, and in this video we're going to look at evaluating the derivative of a natural exponential function. So for this first one, we're asked to evaluate the derivative at 2 of this function, and this one it's a natural log with an exponential in it. So let's see what we can do with that. So remember, in general, for a natural log, if we have natural log of something, the derivative of that is 1 over the something times the derivative of the something. So that's what I'm going to set up here, because this is natural log of a something. So we're going to end up with 1 over the argument and then that's going to be times, and I think I will write it out for this step, the derivative with respect to x of the argument, and then I'm going to show that as another step. Just have that a little bit bigger so I can point at it as I do the work. So I'll copy this down and come back. Okay, so the derivative of this piece, we're going to have the derivative of 4x, so that will just be 4. And then the derivative of the exponential, so that will just be itself, but then times the derivative of the exponent. So actually that's going to change that over to a minus right there. So I'll just put it'll be times negative 0.03, so I'm just going to put it in front, and then our original. And then all I'm going to do is rewrite this with this up in the numerator just so it looks a little nicer. Okay, so there's our derivative. If you're having any thoughts of some sort of canceling, they're not good thoughts. You'll want to let those go. If you can't factor something out that's common to every term, you cannot cancel, so no canceling here. All that's left to do is just to very, very carefully plug a 2 in for those x's and try to get all that in the calculator. And it should come out to 0.4442. Again, if you kind of want to check your calculator steps to see if you're inputting things correctly. Okay, so this one, if a person takes a prescribed dose of 5 milligrams of Valium, the amount of Valium in that person's bloodstream at any time can be modeled with the exponential decay function of a of t equals 5e to this negative rate t, where t is in hours. So we got 3 parts here. How much Valium remains in the person's bloodstream 12 hours after taking a 5 milligram dose, round to the nearest tenth of a milligram. Okay, so all this is asking for is, well, first let's go back. What does the function do again? It gives us the amount of Valium in a person's bloodstream at any time after so many hours. So they want to know how much is in the bloodstream after 12 hours, not a derivative or anything. So part A is just finding A of 12. That's all you're doing. So 5e negative 0.0157, and then 12 hours goes in for our time, and you just chuck that in the calculator, and that's going to give you A of 12 comes out to 4.1 milligrams when I did it. For part B, how long will it take 5 milligrams to decay to 2.5 milligrams in a person's bloodstream? So in this one, notice they gave me time, so that was nice. In this one, they gave me amount, so that is not as nice. That means I know what would be kind of like the y side of the equation, and now I'm trying to solve for the x side of the equation, which in this case is t. So this is where we have to use some of that stuff that we looked at back in solving exponential equations. So setting this up, I'm going to get 2.5 milligrams out, starting off with a dose of 5 milligrams, e to the negative 0.0157 t. So I want to divide over that 5. And what that will do is give me a 0.5, because we're basically finding the half-life of this medication when there's half of it left in the person's bloodstream. And then remember, when we're trying to solve for an exponent, that's why we have logarithms. Logs find exponents. So we will natural log both sides, and that allows us to bring this down front by that property 3 from a couple of sections ago. So I have ln of 0.5 equals negative 0.0157t, and then that's times natural log of e, but remember that equaled 1. So then we just divide over that decimal. And that goes in the calculator. And then we're supposed to round this one to 2 decimal places. So when I put that in the calculator, I got 44.15 hours. And so then for part C, at what rate? So there we see the word rate. So that means we're going to need to find A prime of T, right? Because that gives us rate. So at what rate is the amount of Valium in a person's bloodstream decaying 3 hours after 5 milligram dose is taken? So essentially we want to just find the derivative and then evaluate it at T equals 3, and that will give us what the rate of decrease is at that time. And we're rounding that to 3 decimal places. So A prime, actually let me write down A of T so it's a little bit bigger so you can see it. Okay, so to find A prime of T, we're just going to have 5 times that, remember there'll be the derivative of the exponent times the function. So that will look like if you go this times that 5, you get negative 0.0785. And then that just times this thing again. So that will be our derivative, and then we just evaluate that at 3. And when I plugged in 3, I got negative 0.075. So the units on that would be milligrams per hour if we needed them.